Hey everyone, this is just a quick video on rotation. This is the second example, and it's just that a disk of radius r equals 2 meters rotates 120 degrees from the initial position counterclockwise in this diagram, and when point P is 60 degrees above the horizontal, so somewhere up here, the angular velocity omega is 5 radians a second, and the angular acceleration is alpha equals 3 radians a second, but they're acting in the opposite direction. So the angular velocity is traveling counterclockwise and the angular acceleration is clockwise. For this instant, determine the velocity and acceleration of point P. Now, the way we go about doing that is by saying that the velocity of point P, so V of P, equals omega cross r from the origin to P, and that's omega k cross r cosine theta I plus sine theta j. And we know that it was 5 radians a second in the counterclockwise direction, so this is 5k multiplied by 2, because the radial length was 2 meters, so 2 times cosine 60, because it's at 60 degrees, I, plus sine 60j. And that means that our velocity, so Vp, is equal to, if we do this, it's 10 cosine 60j, so 10 cosine 60j, k cross j is negative I, so minus 10 sine 60I. If we plug that in the calculator, we get negative 8.66 I plus 5j meters a second. So that's our velocity. So the next thing that they've asked for us to find is the acceleration. Now we know the acceleration equation for rotation is a combination of omega cross r, so it's the time rate of change of omega cross r. So the best way to go about this is to look at our velocity equations. Now just give me a sec. Our velocity equations for motion, for acceleration. So we know an acceleration equation. So this is just a of a. This is our general equation. That's d on dt of omega cross r, which is alpha cross r plus omega cross r. And we know what all of these terms are. Our radius is from the origin to point P. Our alpha term is our negative 3 radians a second squared. And our omega term is our 5k radians a second. So what we're going to do is we'll substitute those values in. So acceleration of P here is equal to negative 3k cross 2 cosine 60I plus sine 60j. And that is so we also get plus our omega term, so 5k cross 5k cross 2 cosine 60i plus sine 60j. Okay, so what we end up with is this can be simplified because we've already found it in terms of our velocity. So this term, omega cross r, is our v of p. So this can be further simplified. We get alpha cross r plus omega cross v. And this simply equals negative 6 cosine 60 j plus 6 sine 60 I plus our omega cross v term. So our omega cross v is 5k cross it was, just give me a sec, it was 10 cosine 60, so 10 cos 60 I, sorry, 10 cos 60 j minus 10 sine 60 I. So if we express these in terms of sines and cosines, we can then simplify the term at the end. So we'll end up with 50 or negative 50. So this is just for this term here. So second term is equal to negative 50 cos 60 I minus 50 sine 60 j, and then we'll add in the other term now, so minus 6 cosine 60 j plus 6 sine 60 I. So if we collect like terms, we get negative 50 cosine 60 plus 6 sine 60 I plus, actually it should be minus, we'll get rid of that, minus 50 sine 60 plus 6 cos 60 j. Alright, if we plug that in the calculator, we get negative 19.80 I minus 46.30 J. So there we have it. And this is in meters a second squared. So our acceleration is negative 19.80 I minus 46.3 J meters a second squared, and our velocity was negative 8.66 I plus 5J. So that's our velocity, and this is our acceleration. Okay, thanks for watching.